All right, so I finished my general announcements. Students are reminded that CFU number 6 is something you can retake up until tomorrow. That was given back last week on Tuesday. So students have today and tomorrow to retake CFU 6. CFU 7 was just given on Friday last week. So students have today and tomorrow to make that up. After that, you can have your standard week to take the retake. Okay, in terms of this week, the highlights would be, we'll be taking a CFU on Wednesday. That will cover 2 major topics. One is compound interest, which is what we talked about in class last week on Thursday and Friday, and then graphing with the value E, something we're going to talk about today and tomorrow. Okay, students will receive the review packet for this unit test later this week. That review packet, along with homeworks 29 and 30, will be unpaid next week. And once again, I keep stressing, if you don't think you're going to be here on the half days next week, please arrange to take the test this Friday. You do not want to come back from Thanksgiving break, and my welcome back is move to the back of the room and take this test that you never took. Don't do that to yourself. Okay. All right, here we go. And again, we'll get through this material more quickly if you all are willing to help. So here we've got complete all the properties for the graph below. Let's start with domain. How far left and right does this function go, folks? That should be the whole room that can tell me how far left and right this function goes. Negative infinity to infinity. You got it. So your domain, this function goes left forever, it goes right forever. How about the range? Someone other than Daniel or Roy, since those two just helped me out with that one. How far up and down does this function go? I like the infinity. The 0 is a good, but wrong answer. Not 0, 2. Question is, what's the range? Not 3.
Got it. Who just got it?
Oh, you got it? What was it?
Yeah.
Like, is it
Where's the bottom one?
Negative 1 is the number I'm looking for. So this function, the lowest it goes down, you notice it has a horizontal asymptote. Remember, dotted lines mean they're not actually part of the function, but it's something you need to think about when you're thinking about the function. So that dotted line is the asymptote. It's occurring at y equals -1. So that dotted line is kind of like this invisible barrier that the function can never get to. So the lowest it ever gets is it gets really, really, really close to -1. And Lucas was absolutely right, by the way, that this thing shoots to positive infinity. Okay. How about the y-intercept? Allison?
Can I go to it?
Sure. What's the type?
Grow.
It is growth. So keep in mind, you want to consider from left to right, what is the function doing? And from left to right, this thing is going up, 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 and it never stops going up. Now, how about the y-intercept? Where does this thing hit the y-axis? At 3. But remember, do not just say 3. The y-intercept is a coordinate point. So is it 0, 3 or 3, 0?
Wait, someone.
All right, I'm getting different answers. Jamel, what are you going to say? It's going to be 0, 3. So do not say 3, 0. This point is 3, 0. And that is not the y-intercept. Okay, the y-intercept is here. And that point is at 0, 3. So that is what should be listed here. Okay. So, as I said, these are features we hopefully are already still comfortable with. You absolutely, on your test next week, on Monday and Tuesday, there will be questions that test, can you tell me this type of stuff? Can you look at a graph and name the domain and the range? Can you name the horizontal asymptote? Can you name the y-intercept? Do you recognize is it growth or decay? I absolutely will still be assessing these. Okay, this was kind of where this unit was the very beginning of this unit. And that's what the test does. It tests everything in the packet. All right, go ahead and turn the page. I'm going to give you some fill in the blank notes, and I'm going to end on 2 other examples. So like I said, the more you all are willing to help me, the faster we can get through this. All right, so this is going to be a summary of some stuff that we should already know, but it's also going to introduce the number E, which is something brand new. Okay, so an asymptote is a line that the graph of the function continuously gets closer and closer to, but it never what? It never touches. You got it. It never touches. Even though it looks like it will touch it, the equation of any horizontal asymptote is Is it y equals a number or x equals a number? Picture a horizontal line and ask yourself, which axis does that line cut through? Not x. Okay, so it's gonna cut through the y-axis. If you picture a horizontal line, I don't care where that horizontal line is. No matter where you place it, you got it. It's gonna slice through the y-axis. That's how I like to remember it. Like if I back up for just a moment, that dotted line, it's cutting through the y-axis at -1. That's why the equation is y equals -1. Okay, so every horizontal asymptote is going to have the form y equals some number. Remember, the base of the function tells you if the function represents growth, if the base is bigger than 1, or decay if the base is between 0 and 1. So if it's bigger than 1, it's growth. If it's smaller than 1, it's decay. Make sure we put those phones away, folks. I appreciate it. Now, here's where we're going to get to the new thing. So everything that I've said so far is a summary of stuff we should already be comfortable with. But now we're going to introduce a new type of base. In math, E is a special number called, I'm curious if anyone is willing to attempt to read that word because. So Euler is a good attempt. That's the common wrong pronunciation. Say it again. Euler's again. Euler's just like why. Yeah, that's how I would say it. It's really weird. It's actually pronounced as though it starts with an O. It's Euler's. Euler's. Okay. So in math, E is the special number called Euler's number. Its decimal value from the calculator is. Now, here's where I want people to do all the time to your calculator. We have to know how to get this number. Everyone press second and then division key and hit enter. Okay, that is the number E. And this number pops up in nature. Okay, it's actually a mathematical number that pops up in a lot of ways naturally that we've discovered in just exploring the world. Okay, and it pops up in a lot of useful math applications. Okay, and I'm actually going to show you it's kind of a bridge in compound interest. Okay, I'll get to that tomorrow, but trust me, some uses are coming up. Now, I always go to the third decimal, so I'm not going to copy that whole ridiculous, annoying number. I just say 2.718, and the number after the 8 is a 2, so I'm going to keep the 8 and 8. I'm not going to round it up. Hey, what happened? I accidentally minimized. There it goes. All right. So this decimal number, like pi, never stops or repeats. Since E is greater than 1, the function y equals e to the x. Please write that down. This is the parent function. This is like the simplest Euler function I can give you for exponential growth. It's e to the x. Okay. This would represent growth because e is 2.718. Bigger than 1, it represents growth. Okay. All right, so we're going to do two examples. One is similar to something we've seen many times in the past. The other, the numbers are going to be kind of ugly because it has e as a base. But the process is basically the same for both of these. Okay, in each of these problems, the directions say, create a graph of each of the following, plot and label at least 4 points on each. I'm going to tell you once again now, we are going to get ugly decimals for E, for the graph on the right. So accept that ahead of time. Okay, but we're going to start with the graph on the left. I would encourage you to follow along with me because, again, we have to maintain our comfort with the calculator. I'm going to go to y equals and type 2 times 3 to the x. Okay, I go to y equals, and then type 2, parenthesis 3, close parenthesis, raised to the x. Right? I see 2 people not using a calculator. Again, I would recommend you do this, practice this yourselves. Hit y equals and then type this in. Now, if you hit graph, you're going to see the thing that we're trying to create. Okay, but again, I want to build a table of values. So what I'm going to hit is second graph. And because we have a chart that goes all the way up to positive 17, I'm just looking for any numbers that are no bigger than 17. I mean, one's one step too big, so if you wanted to take 2,18, I'm not gonna blame you because it's only one off the chart. But I'm definitely gonna take 1.6, I'm definitely gonna take 0.2. And I'll take negative 1.6 because the direction we're using these 4 points. If you want to back up and take negative 2.2 repeating, that's fine as well. Okay, so these are the points that I went. I went ahead and took the 18 because it was only one off the chart. Now, when you graph this, I'm not looking for perfection. Before you graph it though, I would recommend, since this is the thing we're trying to create, and clearly it has a horizontal asymptote at y equals 0, I would recommend you draw that asymptote first. Okay, draw that dotted line, not solid, because it's not actually part of the function. But I'm going to draw myself a dotted line right tracing over the x-axis. So my horizontal asymptote is y equals 0. That's what I just drew. Now at this point, it's a matter of graph those 4 points as best I can, and then do the best I can to draw this kind of curve. Okay? So 2,18, I'll put it in green just because I'm not going to say you have to draw a point that's off the grid. But to me, it's going to help me draw this thing. So I'm going to put a point at 2,18. And I've got 1,6. 0.2. Oh, and that's actually my y-intercept. So I'm going to copy 0,2 for my y-intercept. Okay. And the one point that I would say doesn't have to be perfect, because it's a decimal, this should be kind of reasonable, is -1 and 0.7. So it's -1 and then not quite 1. Right. -1, but not quite 1. All right, so when you draw this, you want to arc this up as it goes to the right. And on the left side, just have it go closer and closer and closer to that horizontal asymptote created. So we have a growth function that goes left and right forever. And for its range, just like one of the problems we saw earlier today, except this one is actually trapped by the value 0. It doesn't go down as far as -1. So my range is going to be -1 to infinity. Okay, so this is the exact same process I'm going to walk you through on the graph on the right. The difference is the numbers are going to be really annoying because we have e as a base, which produces a lot of decimal values. All right, last problem of the day. Yes, we're already there because, like I said, I'm going to hope that you do all some decent time on your homework. So I'm just going to type e to the x. Please go ahead and type this in with me. So I'm going to go to my calculator, hit y equals. I'm going to clear that function out. By the way, if you ever don't want to deal with having to clear things out, remember you can always reset the calculator. 2 plus 7, 1, 2. That's another, I would argue, even more effective way of clearing the calculator. I go to y equals. Remember, your e is attached to the division key. I'm going to hit second divide. That gives me my e. And now I want power of x. So I hit the little caret button right above the division. And I type x. The
I
number
would highly recommend that you reset, because with these calculators being used for AP stats, you have no idea what those traits mean.
That's a good point. My periods 1, 3, and 4 are all AP step, and they do some funky things with these calculators. So getting used to resetting them before you use them, good idea. And now, again, before I get to the table, I want to continue to stress, I'm just looking for numbers that are higher than 17. As long as it's a number that's 17 or lower, I'll take it. And the numbers are going to be ugly. Now, to make it a little less complicated, I'm just going to do 1 decimal. And the reason I'm okay with 1 decimal here is because you all are graphing these points by hand. Okay, whether you write down 2.718 and somebody else writes down 2.7, when you graph it by hand, you're both graphing the same point. You know, if one person graphs 2.7 by hand and somebody else graphs 2.718 by hand, you're both going to have a paper that looks exactly the same. So for this purpose, I'm okay with you only copying 1 decimal. Okay, now I can't go that high. I can't go to 3,20. That's way too high. But I will copy 2,7.4 because the number after the 3 is high enough to make it round up. 1,2.7 0, 1, and because the directions were to get 4 points, I'm gonna back up -1 and copy 0.4. Again, the 0.3 is followed by a 6, so it's rounded up to 0.4. So these are the points I went with. Again, a couple of those are rounded because I said, we're graphing this by hand, 1 decimal is good enough.
Are we gonna require them to put in the asymptote? With the dotted line,
I would say there are going to be situations where the asymptote is going to be required. The directions will specifically say it. So the directions say graph f of x, including the asymptote, yes, you have to graph.
so I would just get in the habit of always putting it there, guys, so you never have to worry about it.
Yeah, and what Mr. Fee is talking about is if you hit graph, see, once again, just like every other exponential function we typically have looked at, it has a horizontal asymptote at y=0. So I would agree with him, it's a good idea to just draw that dotted line as a guide. And go ahead and record that as your asymptote at y=0. What's up?
Get a new microphone.
Oh. No. Alright, now, these ones, again, I'm not looking for perfection when you graph, but it should be reasonably close. The only point on that list that should be graphed absolutely perfectly is the whole number 0, 1, the y-intercept. That point should be in an exact location. All the other ones just need to be reasonably close. Like the point -1, 0.4. 0.4 is not quite halfway between 0 and 1. So I'm gonna go -1 and then put a point that's like kind of halfway, maybe a little bit less than halfway, but anywhere close to halfway, I'm happy. Okay. 1, 2.7. So 2.7, it's closer to 3 than it is to 2. So 1, 2.7, I'm gonna put maybe right there. In a location where it's clearly closer to 3 than it is to 2. Okay, and then 7.4, so 2, 7.4 is not quite halfway to 8. But if it's anywhere close to halfway, I'm fine with that. And again, with those 4 points, this is the image I'm trying to draw. Shoots up on the right side, it curves down to 0 on the left side. So that's what I'm going to try to draw. Shoots up really fast on the right, curves down towards the y-axis on the left. And the features are going to be exactly the same. You've got a growth function with a domain from left to right, infinity, negative, positive, infinity. And you've got a range that goes from 0 to infinity. Okay? Let's start. Yes, ma'am. Well, believe it or not, today is a pretty short day, so we're gonna call it there. I would say with today's class, you all are capable of doing it for 29. It's 2 graphs using E. One thing I'd like to call your attention to, so you're careful about, the second problem has a negative attached to the power of x. So when if you're gonna type that in, remember, don't actually use the minus button. Okay? Use the negative button. It's down here by the enter key. That is how you would type this in. You would not type it in like that. The difference between the two is so small that it's easy to miss. But the one on the top is the negative symbol, the one on the bottom is the minus symbol. And if I try to graph this, it'll graph the first one real quick and then flash an error. Because it has no idea what to do with the second one. Okay? So make sure that when you're typing this in, you type it in using the negative key, which is right by the enter key. Okay. That being said, I'm going to donate the rest of the time to the class to work on homework 29. Thanks for watching. Have a good one.